Hi guys, welcome back. This is going to be part 3 of my series on structs in C++. In this video I want to show you just a couple quick things. I want to show you how to use dynamic memory allocation with a struct, and I want to show you how to pass structs to functions. Okay, so let's go ahead and get started. Okay, so with structs, what we're doing is we're creating a new data type, right? The structs are going to represent an abstract data type, one that's created by the programmer. And if we can use dynamic memory allocation with primitive data types like ints, doubles, characters, what have you, and we create a brand new data type called we create a brand new data type. In this case, we call it a student. Well, then we can use dynamic memory allocation with students. Okay, so let me go ahead and show you how to do that really quickly. Right now, we're going to need to use that new keyword and that delete keyword as we're doing our dynamic memory allocation here. Don't forget, for every new statement that successfully executes, you have to have a delete statement, right? So let's go ahead and write a statement that dynamically allocates a student variable, right? So in order to do that, in order to have dynamic memory allocation here, what we're going to have to do is we're going to have to start off by having a pointer, right? So pointer of type student, and I'll just call this SPTR for short, right? And I'll initialize that pointer to null pointer. Always a good idea to initialize your pointers before you assign a value to them. Okay, so that's going to create a memory location. A memory location or a variable that holds the memory address for a student. Okay, so right now we've created a variable that holds a memory address. Okay, so we're going to need to assign to this variable a memory address. Okay, and where's that memory address going to come from? It's going to come from the new operator, right? So the new operator is what we use in C++ to say, hey, give me a new variable, give me a new chunk of memory, right? If successful, then new returns the memory address. We got to store it somewhere. So where are we going to store it? We're going to store it inside this student pointer. Okay. So anyway, so we want a new chunk of memory address. Well, what type of memory? Well, we want a new student. Right. So there we go. That's going to dynamically allocate for us a student variable. Okay. Now, before we forget, remember, in C++ you have to manage your memory. So before our program ends, if we don't want to have a memory leak, we're going to need to deallocate that memory, and that's where the delete statement comes into play, right? So we're going to have to deallocate or free up the memory just like we would any other data type, right? So line 16, new is going to successfully execute, and so line 20 is then going to deal with that newly allocated memory, right? Okay, so we got this new variable. Okay, so what this is doing, what line 16 is doing, is it's creating a new variable named student, and new is going to return a memory address for that variable, and we're going to have to put that memory address somewhere. Where we're going to put it? We're going to put it inside of a variable that can hold a memory address, and that variable's name in our example is SPTR, and it's a pointer of type student. Okay. All right, so since SPTR is a variable that holds a memory address, we're not going to be able to just use the dot operator as we would with statically allocated memory, right? So that means that we can't do this, right? Dot name equals John, whatever, right? Not going to work. Why won't this work? Because S pointer is not a student variable. It's a variable that holds the memory address for a student variable, right? It's a pointer. So this isn't going to work. So if we want to access the fields that are stored in the memory location whose address is inside of the SPTR pointer, then we're going to have to first dereference that pointer, right? Remember how we can do that? Indirection operator, right? So this little expression here says, go to the memory location whose address is inside of SPTR. And what's that memory location? Memory location is a student, right? So once we've done that, then we can use our dot operator, right? Name equals Hank. Okay. Now if I want to set the ID equals 100, right? I want to set GPA 3.9, whatever, right? So this is gonna work, not a problem, okay? So we can use that for setting values in the struct, but we can also use it for retrieving values. Remember, we have to go to the memory location whose address is inside of SPTR, right? And that memory location is a student memory location, okay? Then we can use the dot operator, okay? Just like we would with statically allocated memory, right? We just have to dereference that memory address that's inside of the pointer first. So let's go ahead and compile and run this just to make sure I don't have any errors that I might be missing so far. All right, I should see my name. And I do, there it is, okay? All right, now, this can be kind of annoying, remembering to do this, right? Deallocating your memory address, right? That's stored inside that pointer, then doing that dot operator, okay? So there's a shortcut that we can use, right? And that shortcut is using the arrow operator, right? So I can do something like this instead, right? I can say SPTR arrow, right? See, in Visual Studio it's nice because it kind of pops up. This arrow is a dash and what is that? Greater than symbol, right? 2 characters, 1 operator. And this right here, okay, this statement right here on line 25, exactly the same thing. For all intents and purposes, exactly the same thing as line 18, right? This is the same as line 18. These are going to give you the exact same results. It's just another way of writing the same thing, right? It's a little bit easier to remember to do that dash and that greater than to dereference the pointer and then use the dot operator, okay? But it's going to work, you know, the exact same. So we can do something like this, right? And if I run this, what we're going to see, right? See my name. Well, we see it twice. Why, right? Because I had my C out statement on line 23 and 27 doing the exact same thing. Okay. All right. So what else do I want to show you here? Right, so I mean that's dynamic memory allocation for a single student variable, right? Not a problem. We've got our new statement here that executes. We got our delete. We're cleaning up our dynamically allocated memory. Okay, so let me show you the next thing I wanted to do in this video, and that's going to be passing structs to functions. So I think I'll just do a couple of simple little examples of that, and let me clean this up here, and then we'll be done with this video. Okay, so let's say that I wanted to write a function that could get student info, right? So I need a prototype that looks like this. I'd say GetStudent, right? Now, what would I use in the parameter list here, right? Well, a couple different ways I could do this. For this example, I'll show you how we could pass or use pass by reference, right? Okay, so student is a new data type, right? And we've added it to the language basically, right? We've added a new data type to the language. Now, if we can pass integers by reference and an integer is a data type, fine. Then that means that if student is a data type, we can pass student by reference. So that's what we're going to do. Okay, so let me then show you the function definition for this. GetStudent. Right. Pass by reference is what that ampersand is indicating. Okay, so now we'll have a student variable that I've created inside of main called student s. But then I'm going to call this GetStudent function, and I'm going to pass it. Well, let's name these different just to keep it straight, right? So we don't accidentally confuse the parameter name with the variable name for main. Oh, let's call the student in main t. Okay? So anyway, so t is uninitialized. T's just got garbage values in it. So I'm going to pass t to my GetStudent function. Okay, now anything that I do inside of GetStudent, right, that I want to have happen to t back here in main, I'm going to do by accessing s here. I've passed t by reference to GetStudent, so there's a link between the parameter s and this variable t student, right? So I might say, have a couple, maybe a cout statement here, give me the name of the student, okay? And then I would do something like this, check this out, s dot name, right? So what's gonna happen? Well, I'm doing s dot name, but remember, s is linked to t, so what this is really doing, this is really like we're doing t dot name, right? Because s is linked to t because it was passed by reference, right? So really what I'm doing is I'm going to be reading into t dot name, okay? So similarly, for ID, right, we can do the same thing. See how Visual Studio populates that for us? Okay. All right, so this is basically saying t dot ID. That's what we're really doing. Okay, and then how about GPA? Okay, so let's see here. This is really saying t.gpa. Okay. So what we can do then is call this GetStudent function. We're going to run this, and anything we do in here is going to be reflected inside of t. Okay. Let's have another function here, and this function, let's use it to print a student. PrintStudent. Okay. And we're going to do the same kind of thing. We're going to pass by reference, okay, because it's more efficient. I mean, you could pass a student variable to a function by copy. You could do that, right? But the downside to that is it's passed by copy. So what are you doing, right? If I was to pass a student by copy to PrintStudent, I'd be copying this object here. I'd be copying this variable. I'd be copying this variable here. I'd be doing 3 copy operations instead of just 1, right? If you're doing pass by reference, all you're really doing is passing a memory address, right? You're passing the memory address, the location of where the student variable is, that student argument variable is. You're not making a complete copy of it, so we're not copying each one of these fields. So pass by reference, much more efficient when using structs, okay? Now, I'm going to be printing the student variable that I'm being sent, right? But if it's passed by reference, there is a risk that maybe I do something crazy, and inside of my PrintStudent function, I have an assignment statement that inadvertently changes the argument, right? Don't want to have that happen, right? What if I'm a maniac and I say s dot name equals dog, right? I'm just like this crazy person. Well, then what happened? I inadvertently changed the source variable that was passed to PrintStudent, right? So a preventative debugging tip to keep that from happening, right? If you did pass by copy, that wouldn't be an issue, right? Because you're just changing the copy, but pass by reference, it's an issue. So what I can do to prevent myself from accidentally going insane and changing the source variable is I can put this little const tag here, right? Const keyword. Right? So if I put const here, then the compiler's not going to let me change anything, right? Because, see, right there, Visual Studio. Because const indicates, hey, this is a constant variable, you can't make any changes, sorry, not going to happen, right? So, you can see if I try to compile this, right, bars all over the place. It's because of this const right here, right? So I can't accidentally screw up my source variable. Okay, so PrintStudent, what I want it to do is just display the name of the student that I passed to it, right? So, cout name, test name, it's cout ID, test ID, right? Cout GPA, right? Test.gpa, right? So GetStudent is going to be responsible for getting the student's information, storing it in T by reference, and then PrintStudent is going to show us what we did. Okay, so we're using T as kind of the go-between, right? We're passing messages from GetStudent to PrintStudent. We're passing the student around. Okay, so that's what the PrintStudent function looks like. Let's compile and run this thing. Okay. So here I am being prompted for the name, right? Hank, ID 100, GPA 4.0, yeah, 4.0. Oops, forgot that I have cin statements, right? So that new line character is getting left over in the inside of the keyboard buffer as a result of this cin statement right here. So the cin.get eats it, my window closes. So how can I fix that? Just ignore that leftover new line character. Oops, semicolon. Right? So let's try that again. So Hank, ID 100, GPA. Well, it's not 4.0 if I forgot that last part, right? It's a 3.9. Okay. So first three lines, my GetStudent function. Last three lines, my PrintStudent function. Okay. All right, so let me show you the alternative to GetStudent. Let's overload GetStudent and do a different version. Let's show a different way of doing it. Okay, because we can return structures from functions. Okay, so we can do something like this: student GetStudent. Right, and check it out. My parameter list empty. Okay, so how am I going to make this thing work? What am I going to do? Okay. Well, let me get rid of this. Let me comment this guy right here. Okay, what's going to happen is that I'm going to have a temporary local student variable inside my GetStudent function, right? So student P, right? This is local to GetStudent. Okay, and what we're going to do is we're going to have some statements in here that are going to populate that P variable, and then we're going to return it when we're done, right? We're going to return it. Return by copy, okay? Not the most efficient thing in the world. To be honest, the GetStudent using pass by reference up here is going to be more efficient, because when we return this local variable, what are we going to have to do? We're going to have to copy, we're really returning three variables. When you think about it, we're returning the string, right, the name, we're returning that int, which is the ID, returning a copy of that GPA. Okay, so GetStudent here, reference parameter, still more efficient, but hey, I'm showing you another way you can do it, and you can return structure variables from functions. Okay, but anyway, you know what? Why don't I just copy and paste to save some time, right? Because we're basically doing the same thing, but just different. Same but different. Okay, so it's not the same as saying t.name, t.id, t.gpa, because we're setting it to these local variables, right? We have this local variable, this local student variable p that we're returning. Okay, so we're going to populate this p, return it by copy. Now, how am I going to use it inside of me? Well, I'm going to do something like this. I'm going to say t equals GetStudent, right? So it's not passed by reference anymore, right? We're going to return by copy, right? So there's what our call looks like, and we're just going to copy to t what GetStudent returns. What's GetStudent going to return? Copy of this local variable p that we're filling out with these lines here, right? And so that copy is going to be stored inside of t. When this GetStudent function finishes, the local variable's gone, but okay, fine, who cares, right? Because we already copied it to t. Okay, so let's compile this thing and run it. Let's prove that works. Okay, so there's that GetStudent function, right? That new GetStudent function on line 23. Name Hank, right? ID 100. How about I get a 3.91 GPA this time, because I'm showing you something new. Okay, so print function, first three lines, or excuse me, the get function, first three lines, print function, last three lines. Okay, so let me show you one more thing, one last thing. Since we were dealing with dynamic memory allocation and pointers, how about I write a PrintStudent function that accepts a memory address for a student, right? Okay, it does something like this. Okay. Going to be different, right? We're accepting, or what we have is we have a pointer to a student in this PrintStudent function, right? So we're going to be passing by pointer, right? Which means we're going to have all the baggage that goes along with that. But oops, we're still going to be able to use this function. We're just going to have to do a little bit. We're just going to have to do a little bit more work. It's going to be similar to, close to pass by reference, right? It's just lower level because we're using pointers. Okay, so let's do our PrintStudent function. Okay, so void PrintStudent, right? And I am passing by pointer p here. Okay, I'll name my pointer parameter p. Why not? Pointer p, right? Okay, so I want to print my student out. So I'm going to have, right? Let's have the name. Now remember, memory address. It's going to be a memory address in here. We're not copying a student. We're not passing by reference. What's going inside of p is a memory address. That's a value. We can't use a dot operator on it. If we do, that's what's going to happen. Program compiles, crashes, right? Can't dereference, or you can't use the dot operator on a memory address. It's not a student, okay? So what do we got to do? We got to dereference again, right? So we can do that, okay, just like explained earlier, okay? Or we can, and I'll show you two different examples here, I guess. Or we can use that arrow operator, right? In this case, ID, right? Now I could just as easily have done, here p name. They're the same freaking thing, okay? Whichever one you prefer, hey, knock yourself out, right? Okay, so let's do the GPA. Okay. So what are we doing? We're getting the memory address for a student passed to this, and then we're having to dereference that memory address. Go to the memory location, whose address is inside of P, and then access the name field at that location. That's what we're doing, similarly with ID and GPA. Okay, now, got to call this PrintStudent function, right? Let's comment out the original one, get rid of that. How am I going to do that? Okay, well, I can't say GetStudent T, not going to work, right? Why not? Because, well, I say that, but the overloaded version is the one that's being called right now, right? Or the original version is the one that's being called right now. So let me get it out of here. To show you that it's going to freak out. The Visual Studio is going to say, nope, you can't do that. Sorry. Right. Okay, so now commented out the original version that did accept a regular old student variable. But now check it out. Get student here, T, freaking out, right? Why? Because, okay, oops, I wanted to do PrintStudent. Sorry. I wanted to be with a different PrintStudent. Oops. Commented out the wrong thing. Duh, jeez. Okay, PrintStudent T. Okay, there we go. What's coming out? This version, that's what we want to do. And we want to come out this version. Okay, now I think. Okay, there we go. It's 2 a.m. in the morning. Cut me some slack, okay? All right, anyway, so as I was trying to say, right, I'm passing a regular old student T variable to PrintStudent. Not going to work. Check it out. Right, Visual Studio freaking out. Why? Because the parameter is a pointer. It's expecting a memory address, not an actual variable, right? So I got to pass a memory address to this thing. So right now, student T, statically allocated. So what I can do is I can say, all right, let's pass the memory address of T, right? And that'll work. Okay? So we do something like that, right? So now, using the address operator, get the memory address of T. That's getting passed by copy into our PrintStudent function here, right? And then this thing's going to work. Let's check it out. Okay. Name Hank, ID 100. GPA, gotta go back down to 3.4, right? I made that mistake, right? Commenting out the wrong thing. But once I hit enter, there's my GetStudent function, first 3 lines. There's my new PrintStudent function, last 3 lines, right? Passed by pointer. Okay. So let's do one last thing, and then we'll bring this video to a close. Right? Let's say that I wanted to do dynamically allocated memory. Right? So let's change this to dynamically allocated memory. Student okay, can have a lot of things breaking, right? Let's fix them, and I'll explain why they're broken. Okay, so GetStudent right here, this is broken because GetStudent's returning a copy of a student variable, right? But T, since I put this asterisk here now, T is a pointer. It holds a memory address, not a student. Completely different thing, right? So the return type is now wrong for GetStudent, right? Because look, GetStudent, student variable, okay? So what am I going to do instead? Well, there's a couple things I could do, but what I'm going to say is, or what I'm going to do is, I'm going to dereference that memory address inside of T. So now, by using that indirection operator, what's happening is this is saying, go to the memory location whose address is inside of T and copy what GetStudent returns to that place, right? We're taking that student that GetStudent is returning, and now we're going to copy it to the memory location whose address is inside of T. We're not copying it straight to T, because T is a variable that holds a memory address, not a student, okay? First thing. Second thing we got to fix, line 28. Check it out. Now, we got a problem here, right? What's this problem? Well, thing is we're not passing the memory address of a student anymore, right? Because T, not a student anymore. It's a pointer. It's a variable that holds the memory address of a student, right? So what we're actually passing now with that ampersand is the memory address of the pointer, not of a student. Two completely separate things, right? So we want to pass the memory address of a student. Where's that memory address being stored? Inside of T. T is a variable that holds the memory address of a student. We don't want the memory address of T, we want the contents of T. Get rid of that address operator. Everything's fixed, right? Fixes that, okay? So let's not forget to delete our student, right? Because we're using dynamic memory allocation now, okay? So let us compile and run this just to prove that it works, right? I didn't change my GetStudent function. I didn't change my PrintStudent function, right? All I did was change what was getting passed and what was getting assigned to, right, upon returning from GetStudent. Okay, so I compile and run this. Here we go. Here's my GetStudent function, right? That's my GetStudent function, line 25. GetStudent's going to return a copy of a student, and that's going to be assigned to the memory location whose address is inside of pointer T, not to T. T is nothing more than a variable that holds memory address, right? So Hank, ID 100. That sounds a little smarter there, so we'll go boost my GPA back up to, I don't know, 3.65. How about that? Right, going to do that. Then that PrintStudent function is going to run. Right, we're still passing by pointer with PrintStudent. T has got a memory address inside of it. Memory address for a student object. Where'd that student object come from? Came from GetStudent. Okay. Hit enter. There's my print function. Pass that memory address to PrintStudent. PrintStudent does its business. Right. Pointer now. Okay, I feel like I threw a ton of stuff at you. Hopefully you're okay with that. Maybe you'll have to rerun the video a couple times. I'm talking a little bit faster than I normally do. I just wanted to stuff a bunch of stuff in this video and not have it take forever. So let's go ahead and finish up there. Sorry about the little mistake in the middle there. Sometimes I lose my train of thought. Anyway, as usual, if you have any questions, feel free to email me or stop by my office hours. If you are a student of mine, if not, or even if you are, right, and you found this video helpful, hey, why not give me a thumbs up? Why not leave some comments? Let me know that it was helpful to you. I really appreciate it. Okay, so that brings this to a close. Next video, we'll do some more stuff with structs. So should be up in about a week or so. Anyway, thanks a lot. Really appreciate it. Take care. We'll see you next time.